How do portals distinguish between real photos and edited photos? What are the exact details that denote an edited photography? Of course, this is a complex and evolving field, often referred to as digital image forensics. Portals, like social media platforms, stock photo sites, or verification services, use a combination of automated tools, machine learning models, and sometimes human review to distinguish real from edited images. There is no single magic bullet, but rather a process of looking for inconsistencies that betray digital manipulation. Here are the exact tools, techniques, and details they analyze, broken down into categories. 1. Metadata analysis, the first and easiest check. Metadata is the information embedded in the image file itself. EXIF, exchangeable image file format. Data. This is a rich source of information from the camera or phone that took the photo. Tool. Any EXIF viewer, like EXIF tool command line utility or online viewers. What they look for: camera make model. Does it match the expected device? Is it missing? Often stripped by editing apps. Software traces. The software or history tag might show Adobe Photoshop 2.4.5 quote or PixArt, directly indicating editing. Timestamps. Inconsistent timestamps, for example, date created is after date modified, can be a red flag. GPS coordinates. Can be used to verify the location matches the content of the image. Limitation. Metadata is extremely easy to strip entirely or forge, so it's not reliable on its own. 2. Pixel level analysis, looking for digital fingerprints. This is where the deep forensic work happens, searching for statistical irregularities. Error level analysis, ELA, concept. Every time a JPEG image is saved, it's compressed at a certain error level. Edited parts of an image are often saved at a different compression level than the original. Tool. ELA algorithms can highlight these areas. Edited regions will appear brighter or darker than their surroundings because their error level is inconsistent. What it finds: cloning, airbrushing, object insertion, removal. Clone stamp. Detection, concept. A common tool for removing objects is the clone stamp or healing brush, which copies one part of an image to another. Tool. Algorithms look for perfectly identical or mirror image patterns of pixels in different parts of the image, which are statistically very unlikely to occur naturally. Noise inconsistency. Concept. Every digital camera sensor creates a unique pattern of noise, like a fingerprint. This noise is consistent across the entire original image. Tool. Forensic software analyzes the noise pattern. If one part of the image, for example a pasted object, has a different noise pattern or is unnaturally smooth, denoised, it's a clear sign of manipulation. Color filter array, CFA. Interpolation. Concept. Camera sensors use a Bayer filter, red, green, blue, to capture color. A demosaicing algorithm interpolates the full color image. This process leaves a subtle, predictable pattern. Tool. Algorithms can detect if this pattern is broken or inconsistent in certain areas, suggesting those areas were edited. 3. Machine learning, AI models, the modern approach. This is the primary method used by large platforms like Facebook, Twitter, and Adobe. They train neural networks on millions of both real and edited images. Training data. Models are trained on datasets of known real images and known fakes. For example, COCO dataset for real images, face forensics ++ for manipulated faces. What the AI learns. The model doesn't look for one specific thing, but learns to recognize the countless subtle statistical artifacts and textures that editing introduces, which are invisible to the human eye. Deepfakes and face swaps. AI models are exceptionally good at detecting subtle biological inconsistencies in deepfakes, like irregular blinking patterns, unnatural skin textures, or lighting that doesn't match the rest of the face. Adobe's Project About Face. A famous example where an AI was trained to spot edits made specifically with Photoshop's Liquify tool by looking for warping artifacts. 4. Physical and lighting inconsistencies, human review. Sometimes the best tool is a trained human eye looking for logical errors. Lighting and shadows. Direction. Are all shadows cast by objects consistent? Do they all fall in the same direction with the same length? An inserted object often has the wrong shadow. Highlights. Do highlights on different objects correspond to the same light source? Perspective and geometry. Do lines that should be straight, like building edges, show unnatural warping? Does the perspective of an inserted object match the perspective of the scene? Biological inconsistencies, for portraits. Eyes. Do the reflections in the eyes match the environment? This is a classic forensic technique. Teeth. Are they too perfectly aligned and white, suggesting a smile swap? Skin. Does the skin texture around the edited area, for example, a wrinkle removed, look unnaturally smooth compared to the rest of the face? Fast facts. Subtitles in both English and Spanish. At the end comment, provided by www.laprove.com, source of nopal and worm salt. 60sec University created partly by AI and humans. Despite disadvantages, there is one plus. AI can scrape latest info from global internet.